guys, last class we had a look at how the trig ratios of sine, cos and tan allow us to find angles. Today we're going to have a little look at how that knowledge can help us figure out other measures, side lengths and so on in right triangles. Okay, so let's say I wrote this down. Cos of 50 degrees, remember cos of an angle means it's asking for a ratio. So let's say we knew the cosine ratio for 50 degrees was 5 over, well, I don't know, call it a length. Okay, what does that really mean? What is this statement here saying? It's saying, well, okay, I'm talking about cosine of 50, so it's saying in a right triangle, there exists an angle of 50 degrees, okay. So we know straight away the other angle is 40 degrees, don't we? Okay. All right, and it's saying for this angle of 50 degrees, we have the cosine ratio, which of course is the adjacent side over the hypotenuse. Okay, so let's go over and have a look at this triangle here. All right, first of all, what happened to my cos? All right, let's have a look, see if I've drawn this to scale. So I've got my protractor here, let me take this up. I'm hoping, there we go. So I'm going to be looking at this angle here. I've got a pretty good 50-degree angle there. So let me go and label that. Let's put, there's our 50 degrees. And according to what we've got here, we know the adjacent side's got to be 5 units. So let's just check. I've got the, let's just check our length here. I've got my upside down ruler. 5, let's go there, okay. So you can see there from 0 to 5. So that length there is clearly 5. So if I go over here, I can put down 5. Now it's asking for the hypotenuse here. So this is the side I don't know. Well, of course, if we've got a scale drawing, as we do here, we've got our fixed angle, we've got our fixed adjacent side, we've got our right angle. I've definitely made that a right angle, so we should be able to measure this. So let's have a bit of a play, see if we can measure and see what this hypotenuse length should be, such that 50 degrees has a, we have a side of 5 here and an angle of 50 degrees. So let's go and have a look at our ruler here. Rotate it a bit. Wrong way. Okay, let's take this up a bit. Rotate it around a little bit further. Alright, let's see if we can't sort of get an approximate measure for this. Alright, if I mark that off here, it looks to be, to the best of my knowledge, 7.567. I think about 7.7. Okay, so let's just take that ruler down there. It appears that this is about 7.7 centimetres. Okay, so from our diagram, if we have that angle of 50 degrees and the adjacent side is 5, then we should have a length here of a hypotenuse length of 7.7. Okay, so we could draw a scale drawing very similar to what we did last time. There are, of course, other ways of figuring that out. Okay, so just let me get rid of this. We've used our calculator and explored things. We're going to explore the use of the graphing calculator. How it helps us here. So let's just bring him up here. Okay. Now you'll see we looked at those keys before. We had sine, cos and tan. If you just press cos, it's waiting for the angle. It's saying, all right, give me an angle and I'll give you the ratio for it. So let's pick one of the angles that we know. We know the cos of 60 degrees. That's one of those special angles we played with. Cos of 60 degrees is what again? Okay, we know it's a half there. So given that we know our angle, we can get the sine, cos or tan ratio for that angle. So in fact, this quantity here is just a number, isn't it? So we've got it algebraically, we've got an equation where this is a number, and we want to find this. I think we could probably do that. So we're going to use our algebra knowledge to make L subject here. Well, I don't like it on the bottom of the equation, so I'm going to multiply both sides by L to start with. So I'm going to get over the right-hand side, I'll be left with 5. Over this side, I'll have L times the cos of 50 degrees. Okay, that's pretty easy to make subject then. Cos of 50 is just a number, just like cos of 60 is a number, 0.5, a ratio. So I'm going to divide here by cos of 50 degrees. Of course, got to balance it up. Divide by cos of 50 degrees. They'll cancel out. So that length, according to our calculation, we should be able to figure out 5 divided by the cos of 50. Okay, well let's try it, shall we? 5 divided by cos of 50. Once again, I'm in degrees. Let's have a look at what we get. Okay, so we get a number, L equals 3 significant figures, 7.78. And I think before our estimate, if I'm not mistaken, was about 7.7. Yay! There we go. So instead of having to draw up scale drawings, we can use another tool on our graphing calculator, the sine, cos and tan, to find the ratio and help us find unknown lengths in right-angled triangles. Okay, see you next time. But before we go, guys, I'm going to give you a couple of questions to explore before you come to class. Okay, so let's say I had this information. Let me see. Let's say we knew this, that the sine of 38 degrees is equal to something over 9. First thing I'd like you to do there is sketch the triangle. Sketch means, it's not to scale. We just want to have a look at what this right angle triangle is. Where's the 38 degrees? Where's the x? Where's the 9? Okay, that one, I'd like you to find the length x that we're missing there. How are we going to find that? Can we use some of the tools on our graphing calculator, sine, cos and tan for that? All right, I'm going to get you to do one more. Let's say we knew this. That the tan of 72 degrees is equal to 15.3 over a length there. How will we find that length in a triangle? Once again, do a sketch. Always do a sketch to see what you're looking at. Makes it way easier. From that sketch, I want to see if you can find the length L. So what should that length be so that when we've got this ratio here, that'll have an angle of 72 degrees tan ratio. Okay, now you can go and do it. See you next time.